Good morning, good afternoon, depending on where you are. Thank you everyone for joining us for this webinar today, Building More Accurate Spatial Models with Google PDFM Embeddings and CARTO. Before we kick things off, again, welcome. But if you have any questions, please feel free to ask them throughout today's webinar. We'll be collecting those questions in the Q&A box down at the bottom. Click on that, submit your question, and we will get to those at the end. The slides will be sent out at the end as well. So you have a copy of those. They'll probably land in your inboxes tomorrow. And this webinar is also available on demand. So please feel free to share this with colleagues. And if they have any questions, please feel free to reach out to us via the emails and via any account managers or even through LinkedIn to any of our presenters today. All right, so with that, I'd like to introduce today's speakers. So Miguel, over to you, and Gautam, over to you too.
Yeah, so thank you, Josh. So hello, everyone. My name is Miguel Álvarez. I'm head of data science at CARTO. I've been here for a little more than 6 years, and I'm very excited to be here today with Gautam to talk about this geospatial foundation models that are a very exciting thing today.
Hey, I'm Gautam. I'm an engineer at Google Research, and I've been working on geospatial foundation models, throwing a bunch of really useful data sets into something that other people can use for their downstream applications. And I'm really excited for this opportunity to collaborate with CARTO on this webinar and show people how they can use these for themselves.
Okay. So the agenda for today, very quickly. So the idea is we'll have Gautam talking about what foundation models are, geospatial foundations models are in general. In particular, we'll be discussing a little bit more in detail the population dynamics foundation models. Then we'll see how we are integrating geospatial foundation models again in general, but specifically the PDFM embeddings into spatial analyses. And finally, we'll have like a live walk through and demo showing you how this is integrated into CARTO and then how you can use it to run your own analysis. At the end, we'll have around 10-15 minutes for Q&A. So again, as Josh said, feel free to drop any questions you have. And with this, Gautam, I leave the floor to you.
Okay, cool. Thanks. I'll give an overview of the types of foundation models we've been working with at Google Research, and then dive in deeper to population dynamics ones and how we built it. Next slide. The goal of Google is to organize the world's information and make it universally accessible and useful. And we have focused on gathering really important geospatial data sources and then trying to make them more accessible and useful for all kinds of downstream applications. And I'll go into more of what that means. Next slide. Yeah, you can click a couple more times to fill it out. Thanks. We are focused on data sources that enable us to understand weather and climate, to understand how a city is structured, where people are moving around, even the 3D structure, and details about how objects are constructed, and incorporating things like search trends that understand human behavior. And then we're trying to use all of that information to power very specific applications like crisis alerts or public health things. Next slide. I'll give you an overview of, or an advertisement for some of our remote sensing foundation models and how they're structured. And oftentimes what will happen is we can take a huge corpus of satellite imagery or aerial photography and put them into some kind of machine learning model, which is typically self-supervised. And then the outcome of that can be 3 different tiers of models. One is very specific, where we fine-tune it for classifying buildings or solar panels. Another more general tier could be a general purpose object detection model. And you can query it in a 0-shot setup, or you can give it a few examples to try to predict something. And then the other version of this is we can release embeddings or features derived from this model. And then you can feed those features directly into some downstream application to apply it. Next slide. And so this embedding side is something that was recently released called Alpha Earth on Google Earth Engine. CARTO has a nice blog post about this, and I think there'll be a future webinar about it. There's also 2 upcoming remote sensing models based on Sentinel-2 imagery, and a more high-resolution version of these. And these contrast that, where we would release actual models that you would feed in your own data to form some kind of classification afterwards. Next slide. We've applied these types of foundation models to a bunch of object detection and segmentation applications and found we were able to achieve state-of-the-art performance compared to existing foundation models and enable a lot of different use cases. Next slide. And now I'll dive into another class of population or foundation models focused on population dynamics. And the whole point of this project is to come up with a location-specific fingerprint in a relatively compact representation to power all kinds of analyses that deal with humans and populations. Next slide. The types of features that we want to incorporate are to understand the people in certain locations, all their demographics, to understand their health, their well-being, figure out how people are moving around different places, how is the built and natural environment interacting with them to change their behaviors. Also try to index what is the economic activity happening there, the types of jobs that people are able to have, and to get some index into beliefs and values and social influences. And so we have this really complicated constellation of features and signals. And the idea of a foundation model is we can map them all into something that is easily accessible in any type of downstream application you want to do. Next slide. And I'll make this really clear with an example, with clear examples for how we're doing this in the population dynamics foundation model. So for the cases of this webinar, we're focused on the US, and the administrative regions we're analyzing are zip codes and counties. So for each of those zip codes and counties, we've taken the frequency of the top 1,000 search trends. So you can think of the frequency being very different between zip codes or counties. For each of those zip codes and counties, we also look at the most frequent points of interest and maps. And these could be like categories related to cafes or parks or schools. And then we also look at the mobility related to those, like how many people are visiting them. And we encapsulate that in another set of features. And then finally, we have a set of statistics related to weather and air quality for those locations. And we push all of these features into a graph neural network with a self-supervised loss that we train. And the end result of this is that we take this huge set of thousands of features at every zip code and county, and we end up with a list of 330 features, which represents an embedding for each of those locations. And each of these features is different for every single zip code and county. And it's meant to give you a rich sense of what's happening there. And the way we would apply this is we combine it with some ground truth data, and we can empower interpolation where we're missing statistics or data around the country, extrapolation where we might be missing entire states, super resolution where we can go from the county level to a more finer grained zip code, and then nowcasting or forecasting, like shorter long-term forecasting. Next slide. And I'll make this really concrete with an example. We can take the state of New York visualized here, and we can assume that we have diabetes prevalence statistics at the county level. And we want to get them at the zip code level, which we don't have. And so the way we can use PDFM to empower this application is we can generate all of the county level embeddings or features and then train a very simple model like linear regression from those county level features to diabetes prevalence statistics, which we have. Then we can go to the zip code level and generate PDFM features for each of the zip codes and apply that same county level model to generate zip code level statistics. And the whole reason this works is because the PDFM features are available at both resolutions, and we're learning the pattern that maps to these features and diabetes prevalence. Next slide. We've also been able to apply PDFM to forecasting, and the way we've done this is we take another foundation model called TimesFM from Google Research, and this is a general purpose foundation model that's able to do univariate forecasts over time. And so what we've done is for every single geospatial location, you can learn to correct the error based on the specifics for that location. And you can do that at every single zip code and county in the country. And the way this works is that you have a really rich prior based on the embedding or features for that location. And you can try to improve the performance specifically when you know about a location and what types of errors a forecast could encounter. Next slide. We've also benchmarked this set of embeddings across 29 different target variables. They include a bunch of health statistics from census, also socioeconomic ones and environmental ones, and we've grabbed them all from Google Data Commons and Earth Engine. And we've tested them across tasks like interpolation, extrapolation, super resolution, and forecasting. Next slide. We've also benchmarked across those variables against more traditional interpolation techniques like inverse distance weighting, another foundation model based on satellite data called SatClip, another one based on personal photography called GeoClip. And what we found is for most target variables across interpolation and extrapolation and super resolution, we're able to get state-of-the-art performance using these variables in the US, or using these embeddings in the US. And then for the case of forecasting, when we combine the embeddings with TimesFM, we're able to get the best performance compared to a fully supervised approach and the TimesFM foundation model by itself. If you want to learn more about this, we have like a paper on archive, and we also have a summary blog post. And I'll hand it off to Miguel.
Yeah, so thank you, Gautam, for this great explanation of the work you're doing and specifically about the PDFM embeddings. Once we know what geospatial foundation models are and specifically the PDFM embeddings are, the next question that we can ask ourselves is, okay, so how do I integrate this into our spatial analysis? Gautam already introduced some of these examples, like the tests they run with health indexes and socioeconomic data. But again, geospatial foundation model it is not a single purpose model, it's a multi-purpose model. So it can be used for many different purposes. And in that way, the effort that we are doing here at CARTOS, so one of the role that we have in terms of AI in geospatial landscape, so our purpose here is to bridge this gap between all the research that is happening today around geospatial foundation models and real world analytics. We're doing this through four main pillars. The first one is it's been a trusted bridge. In this case, for example, partnering with Google Research to bring foundation models into real world spatial analytics. We'll show you how this is done in a minute. Then the second one is from research to impact. We know there's a lot of research going around this. And then we'll know that the next step is how we bring this to reality. So we need to translate these complex AI breakthroughs into tools that allow different different professionals to get value from out of these models. The third pillar here would be democratizing access to this. So not only creating the tools to access these geospatial foundation models or these embeddings in particular, but also that those tools are easy to use so that you don't need to be an expert, an ML expert or data scientist. Our goal at CARTO is that this is accessible to a broader audience, not ML experts, let's say, alone. And the fourth pillar here would be our goal is like to be an ecosystem builder. So this that we are showing today is part of a broader effort to grow the community around the use of geospatial foundation models for real-world analytics. And the way we're doing this at CARTO is through our product CARTO Workflows. CARTO Workflows is a no-code tool, analytics tool that we have in CARTO. That in this case we have created different components that we'll see now live, different components to integrate these embeddings into your analytics pipeline. So with seamless integration, you'll see that you can just integrate these PDF embeddings or Alpha Earth embeddings, as Gautam was explaining before. They are already available in CARTO, and you'll see now that just you can just drag and drop a component for each of these models, and you will have them in your workflows canvas, and then you can start doing analytics, okay? Because workflows is not just a tool to bring geospatial data, it's an analytics tool, so you have plenty of analytical capabilities around it. So the idea here is that you can reach your analysis by integrating these embeddings into your everyday analysis. So you can combine them with your data. And then the good thing is that CARTO Workflows runs on top of your data warehouse. So in this case, if you're running on top of BigQuery, you have all the capabilities of BigQuery. In particular, you have all the scalability that BigQuery allows you to have. And then all the analysis you run will be reproducible. So this is the way we're doing all the four pillars that we were mentioning before. So we are bridging this gap between research and real-world analytics through these components in workflows with this drag and drop tool that allows many different profiles to run and to incorporate these embeddings into their analysis. And why this matters for practitioners. So basically, the first point here is because you can do more with less effort. If you think about all the different data sources that Gautam was mentioning before that feed these PDFM embeddings, first of all, not everyone has access to that data. Second of all, then if you need to treat that data to transform it so that you can feed that into a model, that takes a lot of effort, a lot of computational effort as well. And right now you have these embeddings available. So you not only have the embeddings, so you not only have access to a representation of that data, but also a representation that also has identified what are the dynamics between them. So that's even a richer representation of them. As a second point here, this expands your toolkit because again, you can run new types of analysis that you couldn't before with this new data, which as a third point here, this improves your decision-making processes because again, you have richer signals or richer data that will give you better insights into how your business behaves or why it behaves in a specific way in a specific location. And this will lead to better decision making. And the fourth point of why this matters is basically to stay ahead. We know that there is a lot going around geospatial foundation models. We already know what's the potential that this can have. I mean, we already have some proof, some evidence of this potential. So yeah, so this is something that you want to do if you want to stay ahead and see how let's say, use all the potential of these new data sources and these models. And to show you this, how this would be integrated into CARTO, so all these data I introduced, we'll do a quick demo. So you'll see how this is actually integrated into CARTO, how easy it is to just drag and drop these embeddings and then integrate it into a workflow. For that, I'm going to jump into CARTO Workflows. For this, we did a specific exercise to predict sales. But again, as a reminder, these embeddings are multi-purpose. So we decided to run this test to predict sales. But again, it could be also used for predicting some socioeconomic index, some health index, also retail sales or real estate prices, for example. The exercise that we are going to be doing here is, well, actually two exercises. This is part of a broader test or exercise or initiative that we ran, that you have all the details in CARTO's blog, in which we wanted to compare the predictive power of sociodemographic data versus embeddings versus the combination of both data sources. So I'll show you how we can build such a model in CARTO Workflows. And then we'll discuss a little bit of what are the results, what are the type of insights that we can get, how they compare to one another, and you'll see how this becomes a richer analysis, and all that I just explained before now makes sense. So as we were saying, in this case, we're going to be using this Iowa liquor sales. This is an open data that is publicly available. Let me quickly show you what this data contains. So basically, we have every single item, so alcoholic item that was sold in Iowa is recorded here. We know the item, we know the location, we know the store, and we know the price, we know the volume, etc. We're just going to keep it simple. We're going to aggregate this at the zip code level and use the PDF embeddings at the zip code level. But just so you know, we have all this detail. Then for sociodemographics, we're going to use sociodemographic data from ACS, so American Community Survey. Again, here we have plenty of variables from population by age and gender. Then we have income, for example, here per capita, median income, income by range, etc. Okay, so you have plenty of data here that we'll use to try to predict these sales. And then finally, what we would like to do here is combine this with the Population Dynamics Foundation model embeddings at the zip code level. So here in Workflows, we have this package called Geospatial Foundation Models right now, as we said. So we have the Alpha Earth and PDFM embeddings at the county and zip code level. So in order to integrate this into your analysis, you just, again, drag and drop, and you have it here. Once you have the embeddings in your canvas, you can explore what these embeddings look like. And again, for every zip code, well, we have information about the zip code, like the name, population, and so forth. But then we'll have all these 300 features that Gautam was explaining before. I'm not going to get into the details of everything that you can do at Workflows, because that's not the purpose of this webinar. But basically, again, since this is an analytical tool, so we can just transform the data, group it, and etc., so that in the end we have data that we can actually combine. So with sociodemographics, since we have it at the zip code level, we don't really need to do anything. Liquor sales, we have it per day and store, so we need to aggregate it at the zip code level for the entire 2022. We selected 2022 because most of the data sources used for the PDFM embeddings model are from 2022, so that's why we selected that year. And then with the embeddings, again, we don't need to do anything in this case because they are provided at the zip code level. So once we have this data ready, we are able to train our model. In this case, for training our model, we're using another extension package at CARTO, the BigQuery ML for workflows, which is a set of 12 components here that allow you to create classification, forecasting, regression models, and then to evaluate your model, to get feature importances and so forth. And these are wrappers on top of BigQuery ML. So you have the capabilities of BigQuery ML, but again, in a no-code approach. Okay, so you just drag and drop a component, you configure it, and then you can run your analysis. So again, not the purpose of this webinar. I'm just going to go to the very specific on how we built. In this case, we are combining all the data sets. So we are building a model. Let me show you here. So we want to predict total sales per zip code, and we are using both sociodemographics and the embeddings. Again, this is part of a broader initiative. If you wanted to just run it with the PDFM embeddings, well, you would disconnect the sociodemographics. If you want to run it only with the sociodemographics, you disconnect the embeddings from the workflow, and you can compare the results, which is actually what we did on the blog post. In this case, again, we're running a random forest regressor. You can select some of the hyperparameters here. And in that case, this is what we get as a result. For example, here we have the attribution or the feature importances that are provided through their SHAP values through BigQuery ML. And this is what we have. So we built a predictive model. We are trying to predict total sales per zip code, and in this case, the best performing model was the one combining both sources, so both the PDFM embeddings and sociodemographics. Then when we check the feature importances, we can see, for example, in this case, the PDF embeddings, the first one, so the one with the strongest performance is actually the 10th out of all the features here, and we can see what explains total sales. The interesting thing about this exercise that I wanted to show you here so that you could see what is the richness of this type of analysis that you can run is that we compared this against another model that we run here, in which instead of trying to predict total sales, which is more an analysis that you would run if you're interested in opening a new liquor store in Iowa or in any other location, we changed the scope here to a more CPG view. Like, okay, so I don't want to open a store, but what I want is to know how to place my product. And in this case, we selected Hawkeye vodka, so we selected one of the products. And what we do is the same workflow. So the only thing is that we are trying to predict total sales of this specific product per zip code. And again, I'm just going to go to the results of this model. In this case, if again the best performing model was the one that used only the embeddings, and well, when we combine them, we can see that they are the 5th and 6th most important features come from the PDF embeddings. Even though, again, as I said, when we do this properly with a pipeline with cross validation and so forth, is the PDFM embeddings that provide the highest performance. But in this case, when running this model, combining both, we can see that, well, the type of the profile, the profile or the type of customer that when we think about liquor as in general is very different than when we go for a specific product. So in this case, if we're interested in this specific product, we can see that there are some features from PDF embeddings that are guiding sales a lot. And then we have other from social demographics that might not be captured by these embeddings. For example, non-family households probably is something that these embeddings don't capture because they don't have the sources to capture this. But this is the interesting thing about this test that we can run, or the interesting thing about having the embeddings readily available in a tool like CARTO Workflows that allow you to just drag and drop them into your analysis, compare how they compare how a model performs when you integrate them, when you don't, and see which one works best for you. And yeah, so again, if you are interested in more details about this analysis that we ran, again, we have a blog post in CARTO's blog where we explain the results we did. Just as a quick summary, again, as I said, when we were comparing, when we were trying to predict total sales, the one that performed best was when we were combining both data sources. When we were predicting specific product, it was the one with using only the embeddings that performed best, which again, it's a very interesting insight here because again, it depends on your purpose. This is why this is a multi-purpose model. So it will work in a way or another. And the interesting thing is to have a tool that allows you to make all these comparisons in an easy way. And with this, well, this is what we wanted to show you as a demo on. So with this, we finish on the whole picture of geospatial foundation model. So we had Gautam introducing us to geospatial foundation models, specifically to the population dynamics, foundation model embeddings. We've shown you how this is now integrated into CARTO and how easy it is to use it. Once you are in workflows, you just drag and drop, you can connect them to your analysis, you can just compare them. And with this, you can get very interesting insights. And with this, we're happy to answer any questions that you might have. So thank you again for all of you for being with us today.
Thanks, Miguel. Thanks, Gautam. That was fantastic. The questions are starting to roll in. So folks, please feel free to use the Q&A box down at the bottom to submit your question. I will start at the top. Can PDFM be used in CARTO by teams not using BigQuery? Miguel, do you want to take that one?
Yeah, not right now. Right now, it's for BigQuery alone. But this is something that it can be discussed.
Got it. That's good. All right. And then Gautam, how about are Google embeddings available for the UK and at the 2 granularities you mentioned?
We do have embeddings for the UK. I think they're at the postal code level only, and they're available to selected partners, depending on the use case right now. So you can reach out and we can talk about it.
Great. Gautam, I'll stay with you as well on this one. So before you mentioned behavioral and functional patterns, could you explain what you mean by that? How are those different from the traditional demographic data you'd get from something like the American Community Survey?
Oh yeah, that's a good question. The difference is that the features in PDFM are meant to be more indirect, but also more general. So in an American Community Survey or a census in general, you might get a question about your income levels, and you would get a specific profile for individuals. And with the PDFM features, for example, a search signal would give you a general pattern of how people's spending behavior is and give you insights into their income levels, their disposable income levels, the types of professions and jobs available in that area. And then also a broader set of information about how a city's structured and the interaction between things like weather and air quality and whether people are going out to parks and they're going outside and where the population is moving around in the city. And you would use all of these features to predict something like income or home prices. But the goal is to be really flexible. So you can ask a lot of different questions and have lots of different target variables that you would try to predict instead of having a set of final categories from a census.
Got ya. Perfect. We had a question come in, Miguel, as you were running through your demo. Is the train test spatially cross-validated?
Yeah, good question. If you allow me, Josh, I'm going to also answer the previous question you
Yeah,
asked
yeah,
me.
please. Please do. Yeah.
Just to clarify, of course, if you don't use BigQuery, you can always use CARTO's data warehouse. So as part of the CARTO account, you also have the CARTO data warehouse, which is run on top of BigQuery. So you already would have access to the embeddings. And then regarding the geospatial cross validation, For again, not for this exercise. For this exercise, we just ran a completely random split of the data without any considerations of space. For the one on the blog post, we ran cross-validation. Again, not spatially, but we checked. So we checked all the folds so that we checked that they were randomly selected in space. So we didn't did it on purpose, but then we checked that all the folds were randomly split throughout the space.
Cool. Alrighty. We'll stay with you, Miguel, for this one too, seeing as you're one of our lead data scientists here at CARTO. When should a data scientist use PDFM embeddings? Is it best to combine them with traditional data, or are there cases where using just the embeddings might actually work better?
Well, this is a very good question, and the idea would be, my advice would be, since it is very easy to just bring PDFMs into your already existing pipelines, my advice would be just to try and incorporate them into your existing models and see how the performance change, and even try your models without your existing data today, just with PDFMs, and see what's the performance, how it changes, and so forth. So I don't think there's like a general answer to that, like answers like every single use case. I think it really depends on what you're trying to model. As we were saying before, for example, for Liquor, probably there's some specific Liquor that is, has a very, very specific target audience that maybe the PDFMs don't capture, or maybe it does, because it's more about the dynamics of a specific location that makes it attractive, that type of beverage, rather than just simple demographics that are static to that location. So I think it really depends on what you're trying to model. So my advice would be to test both things, since it should be very straightforward to do so. Got
it. All right, thank you for that. All right, we've got one question left, so if anyone does have any more questions, please feel free to submit them. Some geospatial data is open source, possibly under ODBL license. How does CARTO join or combine processes work to avoid exposing the output to ODBL share-alike obligations, or is the output then open source also? Sorry for the tongue twister there. Thank you, whoever submitted that question.
So in this case, so the idea here is that if, we are just giving access to, we are giving access to the PDFM embeddings, or the Alpha Earth embedding. So if CARTO is working with some private data that cannot be shared, that would be, that is not something that so the idea of the CARTO platform is that for our customers to actually do their own analysis. So the idea would be like, if we have a customer that has some proprietary data that they don't want to share, they don't need to share it with CARTO or with anyone, because they work on their BigQuery, and they would just, the analysis that I just showed, they would do that same analysis, and CARTO won't have access to their own data. So in that case, CARTO is not, we don't have this risk, because we don't have access to the data, so we don't share it. So that's one of the powers of how CARTO is built. So we connect to your data warehouse. You don't have to share your data with us. So I think this answers the question, but if it doesn't, please let me know.
Alrighty, and then the final question we've got here is: amazing work from Google and CARTO. How long did it take? How long did it take to make the full project? I guess, how long does it take to integrate in with PDFM models, and how long did the project take?
I think the main effort here is on Gautam's side, which is building actually the PDFM embedding. So I'll leave it to you, because then integrating this, this is quite straightforward. It's not a one-day thing, but it's quite straightforward. The main effort here is how you build a model like the PDFM embedding. So I'll leave it to you, Gautam.
Yeah, I thought they were asking, a couple days sounds pretty good to use the CARTO workflow. And it's probably been a couple years for the Google side to like iterate on things and like write this paper and everything like that.
Nice. Alrighty. Oh, questions keep coming. This is great. I noticed the embeddings are named like feature XXX. How explainable are they, or how would I link them to something intuitive, like number of males aged XX, for example?
The embedding is cut up into 3 different sections. So one is related to search trends, another is related to maps and mobility, and then the final one is weather and air quality. And in the research paper, you can see the indices that represent those categories. So if you are having a lot of the features that are driving your analysis come from the first third of the features, it's probably being driven by search trends. And those are the broad like interpretability categories you can use for this. For like a specific demographic or interpreting that, we're not exposing like the actual features to be able to interpret them, but we don't have like a feature that is the number of males at a certain age. That's kind of implicitly encompassed by all these features. If you could if you had ground truth data, you could kind of interpolate it or like use some kind of regression to understand how much you're explaining by the embeddings. But then you're getting into a task of like how much can you predict like a certain demographic. One thing you can do is like take LLMs like Gemini and ask to post hoc like interpret something. So you might use like embeddings to find similar places in the US based on some criteria. And then you can use like LLMs to explain why that might be the case, as opposed to trying to derive it from like the features, which aren't concretely defined.
Awesome. Well, I think that brings us to an end of all of the questions submitted by the audience. So with that, I'd like to thank you both for being fantastic presenters today. Thank you, Gautam. Thank you, Miguel. And thank you to you, the audience, for coming along. As I said, we will share these slides and this webinar will be made available to you all on demand. So please feel free to share it far and wide. And any questions, please feel free to reach out to the CARTO team once you've received those emails. All right. Thanks, everyone. Take care. Have a great rest of your day.